Welcome to Module 5 of LangChain Academy. We're really excited to talk in this module about long-term memory. Now, memory is one of the most interesting ways to personalize AI applications. I want to show you this hands-on with this application I built for myself called Task Maestro. Now, this is an application that I use to manage my own to-do list, so it's something I've built personally for myself, but we're going to unpack this over the course of the module and build it from scratch. Now, here's how it works. I can interact with it and give it general information about myself. I'm Lance, I live in San Francisco with my wife, I have a 1-year-old. And we can see it calls this update profile node, and it updates my general profile. I can also give it general preferences or instructions for creating tasks. Like, for example, I always want it to give me local businesses or services I can use to accomplish things if it's applicable. Now I can give it tasks, and again, just in natural language. It adds it. It also registers some specific places I can go. I can update tasks just in natural language, which is something I really like. I just like the ability to kind of tell it things naturally that I want done, and it automatically knows what to update under the hood. And we can see it confirms that it updates this particular task. Now, I'm running this all on my laptop using the LangGraph Studio application, which means that these to-dos, as well as my instructions and my profile, are all stored locally on my laptop. Now, let me show example usage of this. Often I'll come to my app and just say, what do I need to get done this afternoon? What's nice is it has all my tasks stored in memory, and it remembers who I am, and so it can just look at those tasks and tell me what to prioritize. For example, in this toy case, I have a single task in there. It resurfaces that and tells me this is what I need to get done because I set a deadline for end of day. Now, this is really highlighting the power of personalized long-term memory and AI agents. Now, everything necessary to build this, we're going to go over in this module, and we're actually going to build this app from scratch, which hopefully will be both instructive and useful because you can very easily take this and modify it for your own use case. If you want a task app like this, you can very easily modify this to customize it for your own preferences, or you can take these principles of long-term memory and apply them to other applications. But I do want to highlight that long-term memory and AI agents is really one of the most powerful things to learn, and we're really excited to dig into it in this module. Let's first go over some conceptual foundations, and then we'll dive into the code.
So now that you have a taste for memory with the application that we just showed, let's dig into some of the conceptual foundations that are necessary to kind of build up to where we want to go. So first, what is memory? The classic cog-sci definition is memory is a cognitive function that allows people to store, retrieve, and use information to understand their present and future. Now, in the context of AI applications, which we actually just introduced, you can think about memory in two different ways. So threads in LangGraph store, for example, a conversation history between an AI bot and a user within a single chat session. The user can come back to that chat session at a later point in time, and the thread contains the entire history. Now, alternatively, there's also what we might call a cross-session or cross-thread memory. This is the idea that some information can be persisted, for example, about the user, across all sessions with that user or all chat threads. In the case we saw previously, these would be, for example, to-dos. It could be a user profile, user preferences, or other things. But the point is that this is information we want to be present across every session with the user. So when you think about short-term versus long-term memory, the scope is within session or within thread, or cross-session, across thread. Example use cases: for short-term, persist conversational history, for example, throughout a chat. Alternatively, for long-term memory, remember information about a specific user across all sessions with that user. There's different mechanisms for short-term and long-term memory in LangGraph. We use checkpointing for short-term memory. We talked a lot about that in prior modules of LangChain Academy. Now for long-term memory, we're going to be introducing something new called the LangGraph store. In either case, we can take information from short-term memory, for example, a checkpointer, or long-term memory, for example, the store, and pass it to an LLM to condition responses to personalize them. We saw a bit of that in the demonstration app at the start of this. Now, short-term memory is something we actually talked quite a bit about in some prior modules. And you'll really remember that short-term memory management is often about managing chat histories. There's different techniques. You can, for example, filter or summarize chat histories. Summarization produces kind of condensed representation of a chat. Filtering basically truncates, for example, older messages. Now for long-term memory, it helps to think about this in a few different ways. Here's a framework that I like to think about it. 2 questions. What is the type of memory we care about? And when do you want to update memory? Let's talk about memory types first. So when you talk about human memory, so when we talk about human long-term memory, there's 3 types: semantic, episodic, and procedural. Semantic memory is facts, what I learned in school, the bike model I have. Episodic memory is actual memories or experiences, bike rides I took. Procedural memory is instructions, like the motor skills needed to ride a bike. Now there's been some nice work to map these ideas over to agents, the Koala paper in particular, which is linked here. So in the case of agents, you can think about semantic memory as facts, like facts about a user, or to-dos in my to-do list. Episodic memory, in the case of agents, you can think about as past agent actions, or what the agents actually tried to do. Tools it's tried to use, for example. Procedural is instructions, like the agent's prompt. Now let's talk about these a little bit one by one. First, for facts. How do you structure facts? Well, there's at least 2 ways to think about this. One can be you can structure facts as a single profile. For example, in the app that we talked about, it saved a user profile that contains some general information about me, like my family, my interests, where I live, right? And basically, as I converse with the chatbot, for example, it can update that profile. That's kind of the intuition behind kind of semantic memory being managed in a single profile. And you can imagine that profile just being some general information about a user. Now, alternatively, semantic information can be stored in what we might consider a collection. So in the app we talked about, for example, a collection is my to-do list. So the collection has a bunch of different to-dos, and I want the ability to add to it. I want the ability to edit existing items in the list. So, the mechanism is basically the same. You can take a conversation, you can take an old list, pass both to an LM, and update to create a new list. But this is kind of just a slightly different way to think about semantic long-term memory. And there's some kind of pros and cons between the both, and that they really are for different applications. So profile, a single document, a single easy-to-retrieve representation, for example, of a user, but it can be challenging to maintain as it grows larger. Alternatively, a list, very useful for something like to-dos, which I want to natively be something I just add items to. To-dos are small, narrowly scoped. Now, the con is, if that list were to grow really large, retrieval can be a challenge. So for example, like imagine I have hundreds of to-do items. How do I retrieve them for reasoning? And that you kind of push some of the challenge from management over to retrieval. Now let's talk a little bit about episodic memory. Again, this is kind of past agent actions. We've done some work on this, and there's a lot of literature on the topic of few-shot examples. But that is one very nice way to provide examples or episodic memory to agents. But as an example, you can pass an agent prior reasoning trajectories that it undertook with specific tools to give it a sense for how to use that tool better in the future. In our blog post, we talk about some ways to use few-shot prompt to improve tool calling performance, and in doing so, we show a lot of cases of agent attempting to call a tool, the mistake it made, for example, the user correction, and indeed the correction in the tool call and the final correct answer. So it just gives the agent some specific examples about prior things it's done, specifically prior tool calls, to help guide its future use of that particular tool, as one example. Now let's talk about procedural memory. So there's a lot of interesting work showing that LLMs are actually very good prompters or prompt engineers. We actually did this by teaching Claude to write a high-quality summarization prompt. The intuition is actually really simple. We start with an initial prompt. It's not that good. We pass in papers. We want to summarize them into tweets. Now, it does a first pass. We review the tweets, and we basically give the prompt engineer model some manual feedback. We give it the tweet generated, and we say, I like or I don't like this about it. And then it uses that feedback to regenerate a new prompt, and then we try again. Run that a few times. We found that we could get very high quality kind of paper summarization, matching the style we want, just by giving an LLM feedback to then rewrite its own summarization prompt. Now, this can be used very nicely in the context of long-term memory, where we can take a conversation, we can take some old set of instructions, passable to an LLM, and have an LLM write new instructions which are then saved to long-term memory. And in fact, the final agent we're going to build will use this to update the way I want to kind of manage my to-do list. So again, we can see the different memory types: semantic, facts, episodic, experiences or memories, past agent actions, and procedural, instructions, for example, the prompt. Now, the second question is, when do you want to update memories? There's two different ways to think about this. One is in the hot path of the application. I'm interacting with it, user message comes in, a memory is updated, the chatbot responds, and so forth. That's exactly how the To-Do app that we just showed works. Now, alternatively, you also can abstract the memory creation entirely away from the user. It can be a separate process that runs some period of time later. And there's some trade-offs between these approaches. In the hot path style, memory updating is what we see, for example, ChatGPT did. It's what our application example does. It provides real-time memory updates, and it can be transparent to the user, which is good in a lot of ways. However, memory updating can affect the user experience or latency and may degrade the performance if you have, for example, a complex agent with many other tools, and now you give the agent the additional responsibility to manage memories. Alternatively, you can run memory creation in the background as a separate process, lower risk of user experience, performance, or degradation, but the frequency of memory updating then needs to be carefully tuned. If you want memories to be immediately accessible, then you need to make sure that your memory service is running at sufficiently high frequency such that the memories are created as you need them. So there's some trade-offs, but for now, we're going to be focusing on in the hot path style memory, for example, in what we're going to build here in this course. And we do have a nice template you can refer to that talks a lot about background memory updating. And at the start, we kind of laid the motivation for where we're going here. We're going to build a memory agent. It has the ability to write long-term memories. In this case, long-term memories are going to be my to-do list. This can be easily extended for many other types of applications just by changing the memory schema you want to save. It's also going to update a profile memory, for example, a static user profile, along with a collection of to-dos, like we just said. And it also has the capability to update its own instructions. So it's going to be using both semantic memory for to-dos in a profile, as well as procedural memory to update its own instructions. And over the course of the next 2-3 lessons, you're going to have all the foundations necessary to build this yourself. Let's dive into the code.